headquarters of the United Nations. In 1947, the United Nations commissioned Wallace K. Harrison to lead the international design team to create their new world headquarters to be a symbol of the bright, peaceful future ahead that did not dwell upon the past. After commissioning Harrison, private architectural advisor of the Rockefeller family, architects from each of the founding nations came to New York to take part in the design of the United Nations building. Together, the architects would develop several iterations for the design of the United Nations, both collectively and individually. In total, the group evaluated 50 design themes that were developed over the course of their meetings. In the end, Oscar Niemeyer's strategy that proposed the separation of the Secretariat building and the General Assembly with two large towers as a way in which to create a large civic area across the base of the site was chosen over Le Corbusier's centralized Secretariat building and General Assembly that were vying for a sense of hierarchy on the site. Surprisingly, even though the Council had chosen Niemeyer's strategy as the winning theme, Le Corbusier pressed his design for the General Assembly on Niemeyer as a better location and compositional design than his proposed two towers. Since its completion in 1952, Niemeyer's slender Secretariat building has become the iconic symbol of the United Nations. Niemeyer and Corbusier's design for the United Nations will continue to give promise to a brighter tomorrow that does not dwell on the past, both politically and architecturally. Floor that, although similar, still require distinct designs for the placement of built-in furniture. The plan is composed around a single loaded corridor. Aalto refused to design north-facing rooms since he wanted most rooms to have a view of the river from the east or west, and thus proposed enlarging the rooms on the western end into large double and triple rooms that receive both northern and western light. Built with dark red rustic bricks, the modular piece comes together to create sweeping curves that juxtaposes the solid limestone of the attached rectilinear common room. The common room is a calm, static space in comparison to the movement of the dormitories. The Baker House went through 4 major renovations since it was completed in 1948, including a replacement of all the windows, making the building wheelchair accessible, a renovation of the mechanical systems, and the restoration of birch furnishings. However, despite these renovations, the attention to detail in the Baker House dormitory brought the essence and formality of Aalto's work in America. Cathedral of Brasilia. Having such a significant history, it can be expected that the architecture of Brasilia reflects the richness and prominence of the culture as a planned city. The cornerstone was laid in early September of 1958, when designs were beginning to be proposed and thoroughly planned out by Oscar Niemeyer, with a diameter of 70 meters, the only visible structure of the cathedral being 16 concrete columns with a very peculiar shape. Reaching up towards the sky to represent 2 hands, the columns have parabolic sections. Hand-painted ceramic tiles cover the walls of the oval-shaped baptistery, done by Atos Burcao in 1977. The cathedral is completed with its bell tower, housing 4 bells that were donated by Spain. More obvious details of the interior are the stained glass windows with different shades of blue, white, and brown. Because it is located at the Esplanada dos Ministerios, there is not a fixed community that attends services. A majority of those that come to the Mass are tourists or workers at the Esplanada dos Ministerios. The cathedral is open daily for public visitation, and it's one of the most visited buildings in Brazil. Notre Dame du Rohe. In the commune of Roncham, slightly south of east of Paris, sits one of Le Corbusier's most unusual projects of his career, Notre Dame de Roncham, or more commonly referred to as Roncham. In 1950, Le Corbusier was commissioned to design a new Catholic church to replace the previous church that had been destroyed during World War II. The site of Roncham has long been a religious site of pilgrimage that was deeply rooted in Catholic tradition. But after World War II, the church wanted a pure space void of extravagant detail and ornate religious figures unlike its predecessors. Roncham is deceptively modern, such that it does not appear as part of Corbusier's aesthetic or even that of the international style. Rather, it sits in the site as a sculptural object. Spatial purity was one of Corbusier's main focuses by not complicating the program and removing the typical modern aesthetic from the design. Instead, Corbusier wanted the space to be meditative and reflective in purpose. The stark white walls add to this purist mentality that when the light enters into the chapel, there becomes this washed-out, ethereal atmosphere. The effect of the light evokes expressive and emotional qualities that create heightened sensations in tune with the religious activities. The gentle curving walls act as a practical method of supporting the concrete and masonry construction, as well as the massive curvilinear roof. However, the walls do not solely act as a structural and sculptural elements. They also act as acoustic amplifiers, especially in the case of the eastern exterior wall that reflects the sound out over the field from the outdoor Aalto. The most striking part of Francham is the curved roof that peers up towards the heavens. The curving roof appears to float above the building as it is supported by embedded columns in the walls, which creates a 10 cm gap between the roof and the walls, and that allows for a sliver of clerestory light. Once inside, the curving walls and the roof no longer define the pure essence of the project. Rather, the light is what defines and gives meaning to the chapel experientially. The inability to recognize Francham has made it one of the most important religious buildings of the 20th century, as well as Le Corbusier's career. Guggenheim Museum. Swelling out towards the city of Manhattan, the Solomon R. Guggenheim Museum was the last major project designed and built by Frank Lойд Райт between 1943 until it opened to the public in 1959. The exterior of the Guggenheim Museum is a stacked white cylinder of reinforced concrete swirling towards the sky. The museum's dramatic curves of the exterior, however, had an even more stunning effect on the interior. Inside, Wright proposed one great space of a continuous floor, and his concept was a success. The design of the museum as one continuous floor with the levels of ramps overlooking the open atrium also allowed for the interaction of people on different levels, enhancing the design in section. Walking inside, a visitor's first intake is a huge atrium, rising 94 feet in height to an expansive glass dome. Along the sides of this atrium is a continuous ramp uncoiling upwards 6 stories for more than 1/4 of a mile, allowing for one floor to flow into another. The ramp also creates a procession in which a visitor experiences the art displayed along the walls as they climb upwards towards the sky. Many critics also argue that the building competes with the artwork that is intended to be displayed. In 1992, the museum built an addition that Wright had originally intended. The architects analyzed Wright's original sketches. It is a 10-story limestone tower that was more appropriate for the display of art. Despite the opinion of critics, there is no doubt that Wright's design for the Guggenheim Museum provides a spatial freedom that is unique to his style. It took Wright 700 sketches and 6 sets of working drawings to turn his vision into this extraordinary sculpture of a building. Seagram Building. The 38-story building of Park Avenue was Mies' first attempt at tall office building construction. Mies' solution set a standard for the modern skyscraper. The building became a monumental continuity of bronze and dark glass climbing up 515 feet to the top of the tower, juxtaposing the large granite surface of the plaza below. On completion, the construction costs of the Seagram Building made it the world's most expensive skyscraper at the time, due to the expensive high-quality materials and lavish interior decoration, including bronze, travertine, and marble. Another interesting feature of the Seagram Building is the window blinds. As was common with the international-style architects, Mies wanted the building to have a uniform appearance. One aspect of the facade which Mies disliked was the disordered irregularity when window blinds are drawn. Inevitably, people using windows will draw blinds to different heights, making the building appear disorganized. To reduce this disproportionate appearance, Mies specified window blinds which only operated in 3 positions: fully open, halfway open or closed, or fully closed. The plaza attracts users with its 2 large fountains surrounded by general outdoor seating. By making this move, Mies distanced himself from New York urban morphology, lot line development, and the conventional economics of skyscraper construction. Seagram Building is one of the first modern skyscraper and an example for decades to come. The unique style of Mies' architecture is later used as an inspiration by the next generations of skyscraper architects in the USA. Ingalls Ring. This hockey rink contains a span 200 feet long by 85 feet wide and does so with a natural sense of flow and polish. Though the rink is seemingly heavy and brutal, it is truly a tensile structure. The main structure comes from a 290 feet long central arched backbone of reinforced concrete. From this central support, the timber roof is hung on a cable net structure which gives it the signature double curve. Further cables running from the center arc to the outer edges of the building help stabilize the structure against wind loads. The vast expanse of the center of the dome rises 75 feet above the ice below. A somewhat cavernous sense is felt at the inhabitable levels and opens towards the center. The experience of the interior both reflects and refracts the image of the exterior. The underside of the oak roof adds a sense of scale and warmth. The directionality of the wooden slats trace the stresses of the drapery, punctuated by the penetration of their concrete supports. Bauhaus. Interested in creating a new form of design found at the intersection of architecture, art, industrial design, typography, graphic design, and interior design, Walter Gropius was inspired to create an institution known as the Bauhaus at Dessau, with an emerging style that would forever influence architecture. The extensive facilities in the plans of the Bauhaus at Dessau include spaces for teaching, housing for the students and faculty members, an auditorium and offices, which were fused together in a pinwheel configuration. The building is comprised of 3 wings, all connected by bridges. The school and workshop spaces are associated through a large 2-story bridge, which creates the roof of the administration located on the underside of the bridge. The housing units and school buildings are connected through a wing to create easy access to the assembly hall and dining rooms. The educational wing contains administration and classrooms, staff room, library, physics laboratory, model rooms, fully finished basement, raised ground floor, and 2 upper floors. To incorporate the students of the Bauhaus, the interior decoration of the entire building was done by the wall painting workshop, the lighting fixtures by the metal workshop, and the lettering by the print shop. Like the steel painting, in a sense the Bauhaus was composed of basically related functional elements that produced a cohesive, interrelated, asymmetric whole. Yoyogi National Gymnasium. Built for the 1964 Summer Olympic Games in Tokyo, Japan, the Yoyogi National Gymnasium has become an architectural icon for its distinctive design. Tange's innovative structural design creates dramatic sweeping curves that appear to effortlessly drape from 2 large central supporting cables. Its dynamically suspended roof and turf materials form one of the most iconic buildings in the world. Sitting within one of the largest parks in the metropolitan region of Tokyo, Tange uses the context as a way in which to integrate his building into the landscape. The subtle curves of the structural cables, the sweeping roof plane, and the curving concrete base seem to emerge from the site, appearing as one integrated entity. Similar to Saarinen's design for Yale's hockey stadium, Tange employs a central structural spine from where the structure and roof originates. 2 scale steel cables are supported between 2 structural towers, in addition to being anchored into concrete supports on the ground. The suspended cables form a tensile tent-like roofing structure. A series of pre-stressed cables are suspended off the 2 main cables that drape towards the concrete structure that creates the base of the gymnasium, as well as providing the necessary structure for the seating within the stadium. The result is a symmetrical suspension structure that elegantly drapes from the central structural spine. Its flowing surfaces make the minimal surface structure appear as fabric suspended by 2 simple supports that's being pulled into tension by the landscape, and a quote by Kenzo Tange himself. We, Japanese architects, in our endeavors to resolve the problems facing modern Japan, have devoted a great deal of attention to the Japanese tradition, and have in the end arrived at the point which I have sought to elucidate to you. If, however, there can be detected a trace of tradition in my works or in those of my generation, then our creative powers have not been at their best. Then we are still in the throes of evolving our creativity. I want, by all means, my building to be free of the label traditional. Sydney Opera House. There are a few buildings as famous as the Sydney Opera House. Arguably considered the 8th wonder of the world, the Opera House has a long history behind its design. The story behind this magnificent structure began in 1956, when the New South Wales government called an open competition for the design of 2 performance halls, for opera and for symphony concerts, that would put Sydney on the map. The Danish architect Jørn Utzon was unknown for his work at the time, yet his entry for the competition, which consisted of a few simple sketches, intrigued the famous Eero Saarinen, who was part of the jury. The construction of the podium began when Utzon was not yet done with the design of the opera house, and was overseen by the renowned engineering firm Aalto and Partners. Between 1957 and 1963, in the midst of construction of the podium, Utzon and Aalto worked on developing a shell system that would make the original spherical scene structurally possible. This system permitted each rib to be built up of a number of standard segments cast in a common mold at the side. Utzon wanted the shells to be portrayed like large wild sails, in contrast to the deep blue waters of the ocean it stood upon. In 2003, Jørn Utzon was awarded the Pritzker Prize, 5 years before his death in 2008. Due to political issues that led to his resignation years before, the architect never returned to Australia to experience his finished masterpiece that is regarded as one of the greatest structures ever created.